Hello, today we're going to do another day of standard form when writing equations of lines. So we're going to start off with a couple of review problems just to make sure all of our other equations and everything is going well. So we're going to go ahead and if you haven't done so already, take a look at the warm-up, read through number 1 and 2, pause the video, and try it yourself real quick. So for number 1 here, we get a slope when we plug everything into our formula to be negative 2/5. So this fraction here is not going to reduce, so we're going to end up just leaving it as is. For point slope form, you could have one of two options. You could have y plus 4 equals negative 2/5 x minus 1, or y plus 2 equals negative 2/5 and then x plus 4. Either one of these is totally fine for your point slope form, okay? And for those ones, you would just leave it as is. What we're going to do is we're going to take point slope form and transition into slope intercept form. So I'm just going to pick one of these and I'm going to say y plus 2 equals negative 2/5. And what I'm going to do right here is I'm going to distribute that slope to everything. So I get negative 2/5 x minus 8/5. Then I'm going to subtract 2 from both sides and I get y equals negative 2/5 x. You're maybe going to have to do some work with some fractions here, finding common denominators. We're really doing negative 8/5 minus 10/5. So that means my y-intercept is going to be negative 18 over 5. So this is in slope-intercept form. Now we're going to transition from slope-intercept form over into standard form. So I'm going to move my 2/5 x to the other side. I get 2/5 x plus y equals negative 18/5. At this point, x and y are on the same side. Your a value is positive, but we have fractions. So I distribute 5 to everything to clear those fractions, and I get 2x plus 5y equals negative 18. This then is your standard form. So we're going to do another one with practice with these fractions. We're going to write this in standard form. We're going to go ahead and distribute the 4/9. This is already in point slope form. So we're going to get 108 over 9 when we do that. Now looking at this, we can simplify that a lot nicer. 108 divided by 9 is going to be 12. So I'm going to move my constant over. At the same time, I'm going to move my x to the other side. So I'm grouping my x and my y on the same side. I get negative 4 over 9x plus y equals negative 6. So I have to get rid of the fraction. So I'm going to multiply by 9. But my a value is negative. So I'm going to actually multiply by negative 9. So when I do that, my first term here becomes 4x. Then I get minus 9y equals 54. And this then would be my answer in standard form. Whoopsies, let's try hard. This is my answer in standard form. So let's take a look at these different applications. So why do we have all of these different forms of lines? Well, they're all good for different things, and you'll see that in your applications here too. With these applications, you really have to pay attention to what is given to you in the problem. So for number 3 here, we have Leah spending $150 on musical festival tickets. This right here represents a total. You have reserved tickets for $25. This is $25 per ticket, so this is a rate. But interestingly enough, you also have this general admission cost is $10 per ticket. This is another rate. So if we're trying to write it in a different form, slope-intercept form doesn't work because we don't have a y-intercept and we have two rates instead. So this is a perfect setup for standard form. So the 150 is the total. What I'm going to do is I'm going to say reserved tickets, that's going to be my x value. General admission, I'm going to use as my y value. So these reserved tickets are $25 each. So I can write that as 25 times X. The general admission ticket, the rate for that one is $10, so we're still going to use it like a slope, but it's $10 per Y ticket. So this is my equation then to represent this situation. And you notice this is naturally in standard form because I have two rates in the original problem. So now we're asked if she buys two reserved tickets. Now, as a reminder, my reserved tickets were my X values. We are going to look then for how many general admission tickets we need. So we're going to do $25 per reserved plus 10 times the general admission, which we don't know, equals 150. This now is an equation we can solve. We can subtract 50 on both sides. We would get 10y equals 100 and divide by 10 to get y equals 10. So she would buy 10 tickets for general admission price. Let's take a look at another one. So we have a trail mix. We have this $40. This $40 is my total. We have almonds costing $8. Notice how it says $8 per pound. This is a slope or a rate. The next one also has cashews costing $10 per pound. This is another rate or another slope. Let's say almonds is X and cashews is Y. We can say since my total is 40, almonds are $8 a pound, so we would show 8X. Cashews are $10 a pound, so we would show 10Y. This is my linear equation, and it's naturally in standard form again. So Luke here then buys 2.5 pounds of almonds. Almonds are my X values, so I can do 8 times 2.5 plus 10y equals 40. And I can continue to solve for this. So 8 times 2.5, that's going to be 20, so I can subtract 20 from both sides. 10y equals 20. So you can buy 2 pounds of cashews. So let's try one more applications before moving on to something else. So read through number 5, see if you can set up your equation, and then come back here to see if you got it right. So our equation with this one is 13x plus 18y equals 170 when x are tops and y's are bottoms. Okay, so with equations of lines, we've talked about all of the different types of lines, vertical, horizontal, and also ones that have positive slope and negative slope. What we haven't done is we haven't dove in to actually coming up with equations of vertical and horizontal lines. So a vertical line is going to be the one that is going to be up and down, okay? If you have something that's up and down like this, you're used to seeing that and saying my slope is undefined. You would get, for instance, some number divided by 0 in your slope formula, and you would say that's undefined. If that's your case, the equation of the line is going to be x equals some number. So for instance, if this were our line, all of my x values on this line here, all of them are 2. So the equation of this line would be x equals 2. Whereas horizontal lines go with the horizon, they're horizontally across. So when you do your slope for these ones, this slope of this line would be 0. When you do your slope formula, you would get 0 over some number. But that still doesn't tell me the equation of my line. The equation of my line should be y equals some number. So for instance, this one, if it's up 4 here, every point on this line has a y value of 4. So therefore, the equation of this line is y equals 4. So let's take a look at what that would be like when we actually take and see our slope formula. So 6a here, we want to find the slope of each of these. So we're going to do y2 minus y1 over x2 minus x1. When we do that, we get 0 over negative 7. 0 on top is okay. We do get an answer here. It is 0. But that doesn't mean the equation of my line is 0. When your slope is 0, you have to go back to it and kind of think about what these points would look like. 5 comma 5 is here, negative 2 comma 5 is here. The reason why my slope is 0 is because it's across horizontally, which means the equation of my line is going to be y equals, and the number that it equals is going to be the constant in these 2 points here. You notice we get, for both of those points, y equals 5 is your y coordinate of those points. So I would strongly recommend finding your slope, and if it's 0 or undefined, pause and think about what that graph would look like, and then write the equation of your line. Let's take a look at the next one here. y2 minus y1 over x2 minus x1. You get 12 over 0. This is a no-go. This is your undefined. Okay, so your slope here is undefined. So visually what's happening, 1 comma negative 6 would be down here. And 1 comma positive 6 would be up here. So what's happening is you have this vertical line going through each of these. Since it's a vertical line, it's going to be x equals, and you'll notice here that these ones both have an x value of 1, so that is the equation of my line. So let's go ahead and take a look at C and D. Now visually it's the same as what we were just doing, it just doesn't have the points, which actually saves us some time. So vertical lines have an undefined slope, whereas for D, my slope is horizontal here, it's straight across, so my slope is 0. So my vertical line hits the x-axis, so it's going to be x equals, and you'll notice it goes through 8 on the x-axis. My horizontal line goes through my y-axis down here at -2. So that's going to be the equation of my line. That's another way to do it, is to look at what axis it hits and go from there. So not only can we write equations of these lines, but we can also graph this. So it seems weird for this first one. It says graph this, but it doesn't really have the equation given to us in a nice form. So what we can do is we can go ahead and solve for x. We get x equals -4. So I'm going to go to my x-axis and I'm going to go to -4. And since it's x equals, that means it's going to be a vertical line through -4. My next one here, we can go ahead and solve for y. So I'm going to add 16 to the other side and divide by 2. So the line I'm really trying to graph is y equals. So what I'm going to do is I'm going to go to my y-axis and put a point at 8. Since it's y equals, it's going to be horizontal, so it's going to go across that way. So we should be feeling hopefully pretty good about standard form and vertical and horizontal lines. If there's anything that you have questions on, please don't hesitate to reach out. Thank you very much.